Have you ever looked up at the night sky and felt a strange mix of awe and unease? That sense of wonder is something we all share. But what if I told you that beyond the beauty of those shimmering stars lies a reality far more unsettling than we've ever dared to imagine? Our universe is not just vast and mysterious. It's filled with enigmas that challenge our very understanding of existence. From the eerie silence of deep space to the invisible forces shaping reality itself, there are secrets hiding in plain sight. Secrets that might redefine what it means to be human in a cosmos brimming with the unknown. Today, we're diving into 25 of the most chilling theories about the universe, ideas that venture beyond conventional science and into the realm of the profoundly strange. These aren't just wild speculations, they're possibilities grounded in cutting-edge physics, cosmic observations, and the unsettling gaps in our knowledge. What if our reality is nothing more than an advanced simulation? Could it be that we're utterly alone in the cosmos, or worse, that something out there is deliberately hiding from us? From the haunting implications of the Fermi paradox to the spine-tingling concept of false vacuum decay, these theories don't just make us question the universe, they make us question everything. So join me on this journey into the deepest, darkest corners of space and thought. Together, we'll explore concepts that will leave you awestruck, curious, and maybe even a little unnerved. By the end of this video, you might never look up at the stars the same way again. Let's begin. Imagine if everything you are, your memories, your sense of self, your entire reality, wasn't the product of a lifetime of experiences, but just a fleeting, random accident. A momentary glitch in the silent, infinite cosmos. This isn't the plot of a science fiction novel. It's a real and deeply unsettling thought experiment born from theoretical physics known as the Boltzmann Brain. The idea gets its name from Ludwig Boltzmann, a 19th century physicist who helped pioneer our understanding of thermodynamics. He grappled with a cosmic paradox. Why does our universe appear so ordered and structured when the natural tendency of everything is to descend into chaos and disorder, a state known as entropy? His work suggested that in a truly eternal and infinite universe, even the most incredibly unlikely events must happen eventually given enough time, and that's where things get strange. Proponents of this theory suggest that over unimaginable eons, the random jostling of particles in the vast, empty void of space could, by sheer chance, assemble a fully formed, conscious human brain. Not attached to a body, not born of a universe, but just a lone, thinking organ suddenly popping into existence, floating in the darkness. This brain would, at the very moment of its creation, be equipped with a complete set of fabricated memories, making it utterly convinced that it is a real person with a real past. It would believe it is looking up at the stars from a backyard on Earth, remembering a childhood, a first love, a life, all of it an elaborate illusion. The true horror of the Boltzmann brain isn't its bizarre origin, but the philosophical trap it sets for us. If such random, self-aware fluctuations are possible, then statistically, there should be vastly more of these isolated, momentary brains in the universe than there are real, biologically evolved beings like us. So how can any of us be certain we are not one of them? Your feeling of continuity, your belief in a consistent reality, could all be a deceptive memory implanted in a consciousness that just began a second ago, destined to dissolve back into chaos almost immediately. It forces us to confront the very nature of existence and consciousness, questioning whether we are stable entities in an ordered cosmos or just transient flashes of thought in an eternal and ultimately meaningless void. If the idea of being a momentarily conscious accident feels isolating, consider this even more daunting possibility. What if we are not alone in the universe but utterly and permanently stuck? This is the chilling core of the Great Filter, arguably the darkest answer to the famous Fermi paradox. Physicist Enrico Fermi once posed a simple but devastating question. given the unimaginable size and age of the universe with its billions of Earth-like planets. Where is everybody? The silence from the cosmos is deafening, and the Great Filter theory suggests a terrifying reason why. It proposes that at some point in the evolution of all intelligent life, a nearly insurmountable barrier arises, a catastrophic civilization-ending event that prevents any species from reaching the stars and becoming a truly galactic presence. This is the filter. The reason we see no evidence of other civilizations is not because they don't exist, but because they all, without exception, hit this wall and are wiped out before they can make contact. The true terror of this theory lies in its implication for us. Humanity's rapid technological progress over the last century might not be a sign of our impending greatness, but a countdown to our own collision with the filter. We are, in a cosmic sense, speeding toward a cliff in the dark, and we have no idea how close we are to the edge. The filter could be behind us, a hurdle we miraculously overcame. Perhaps the jump from simple prokaryotic life to complex multicellular organisms was so astronomically rare that we've already beaten the odds. That is the hopeful scenario. The far more frightening possibility is that the Great Filter is still ahead of us. Our own technological adolescence might be what kills us. We are currently playing with forces we barely understand, any of which could be the very event that has silenced every other civilization. It could be the specter of nuclear annihilation, a war from which no society recovers. It might be a biotechnology accident, an engineered pathogen that escapes the lab and ends everything. Or perhaps it is the rise of artificial intelligence, not in a dramatic robot uprising, but in a quiet, logical takeover where an AI determines that the most efficient way to solve a problem like climate change or resource scarcity is to simply remove the most illogical and wasteful element, us. Every new headline about a political crisis, a lab breakthrough, or an AI milestone could be a step closer to that precipice. The Great Filter isn't a distant asteroid or an alien invasion. It is most likely a product of our own ingenuity, a creation born from our desire to progress that ultimately becomes the instrument of our destruction. The eerie silence of the universe is not an empty void waiting to be filled. It is a graveyard, and the most disturbing question of all is whether we are currently digging our own grave. But if the silence of the cosmos and the fragility of our own existence feel like abstract fears, the next theory brings the terror much closer to home. In fact, it questions the very nature of your home, your body, and the world you see around you. This is the simulation hypothesis, the idea that our entire universe and everyone in it is nothing more than an elaborate computer simulation being run by a vastly more advanced civilization. The concept feels ripped from science fiction, but it has gained traction among some of the most prominent figures in technology and science. The argument often starts with a simple logical progression. If a civilization ever reaches a technological level where it can create hyper-realistic simulations of its own history or of entire conscious worlds, it would likely create countless numbers of them. In that scenario, the odds are overwhelmingly high that we are not the original biological civilization, but merely one of the many simulations. So, where's the evidence? Proponents point to what they see as the glitches in our own reality. At the quantum level, the universe behaves in a strangely digital way. Particles don't have a definite state until they are observed, almost as if the simulation is only rendering the details when someone is looking to save on processing power. This is like a video game that doesn't load the entire world at once, only the parts the player can currently see. Then there are the more anecdotal but deeply unsettling phenomena like the Mandela effect. This is when large groups of people share a distinct memory that is provably false, like remembering Nelson Mandela dying in prison in the 1980s, or the Berenstain Bears being spelled with an E instead of an A. Could these be evidence of a software update that slightly altered the past, leaving some with residual memories of the old code? But the true existential horror of this theory isn't just that we might be in a simulation, it's what that implies about our consciousness and our future. If this is all a program, then we are not the players. We are likely the non-player characters, the background entities with no free will, following scripts written by our creators. Our deepest loves, our greatest triumphs, our most painful losses, all could be predetermined lines of code, a narrative written for someone else's entertainment or study. And what happens when the experiment is over, or when the beings running the simulation simply get bored? The most terrifying possibility is the one we can never see coming, the pull of a plug, the click of a shutdown command. Without warning, the entire universe, every star, every planet, and every conscious being could simply cease to exist, deleted into nothingness as if we never were. It renders all of human struggle, art, and emotion potentially meaningless, reducing our entire existence to a temporary data stream in an alien computer. This theory doesn't just suggest we are alone in the universe. It suggests that the universe itself is an illusion, and our place within it is a beautifully rendered lie. But if the idea of our reality being a simulation makes the universe feel fragile, the next theory presents a finale of such absolute and violent annihilation that it makes even the most dramatic supernova seem tranquil by comparison. We're moving from a crisis of existence to a crisis of the cosmos itself with a theory known as the Big Rip. Up until the late 1990s, the prevailing scientific belief was that the expansion of our universe, kick-started by the Big Bang, was gradually slowing down thanks to the relentless pull of gravity. The ultimate fate of everything was thought to be either a slow, cold fade or a dramatic reversal, the Big Crunch. But then, astronomers made a discovery so shocking it upended cosmology. The expansion of the universe isn't slowing down at all. It's accelerating. Something is actively forcing galaxies to fly away from each other at an ever-increasing pace, and we've named this mysterious something dark energy. Think of dark energy as a kind of anti-gravity, a repulsive force woven into the very fabric of space itself. As the universe expands, more space is created, which in turn generates more of this repulsive force, leading to even faster expansion. It's a runaway feedback loop of cosmic proportions. The Big Rip scenario asks a simple, horrifying question. What if this dark energy doesn't just win, but becomes overwhelmingly dominant? In this apocalyptic finale, the accelerating expansion doesn't just move galaxies apart. It becomes so powerful that it overcomes every other force in the universe. First, the vast cosmic structures that hold the universe together would be obliterated. The gravitational bonds tethering entire galaxy clusters would snap, sending them flying off into the ever-darkening void alone. Next, the expansion's force would target individual galaxies. The Milky Way would be torn asunder, its stars ripped from their orbits and hurled into nothingness. But the horror is just beginning. The relentless acceleration would then reach into our own solar system. The sun's gravity would be rendered meaningless, and Earth would be flung away from its life-giving star into the freezing darkness. Planetary bodies themselves would be next. The force pulling space apart would exceed the gravity holding a planet together, and worlds would literally be shredded into asteroids and dust. The final, most terrifying phase would occur in the last moments before the end of time itself. As the expansion force grows infinitely strong, it would target the very building blocks of matter. The bonds holding molecules together would be broken. Then, the atomic forces that keep electrons in orbit around a nucleus and protons and neutrons bound together would be overwhelmed. In the last fraction of a second, every single atom in the entire universe would be violently ripped apart, subatomic particles torn away from each other and unable to ever interact again. The universe would be reduced to a cold, empty, and utterly lifeless sea of isolated particles flying apart at speeds beyond comprehension, with no possibility of any structure, let alone life, ever forming again. Current estimates for when this could happen are staggeringly far in the future, perhaps another 50 billion years or more. But the sheer inevitability and absolute finality of the Big Rip is what makes it so chilling. It's not an extinction, it's an erasure. It's the universe not with a bang or a whimper, but with a silent, infinite scream as every single thing that ever was or could be is systematically and utterly undone. Yet for all its terrifying finality, the Big Rip is only one possible ending for our cosmos. What if, instead of being torn apart, the universe were to collapse back in on itself? This is the premise of the Big Crunch, a dramatically different fate where the expansion of the universe eventually halts, reversed by the relentless, patient pull of gravity. Imagine the grand narrative of the cosmos played in reverse. After billions of years of flying apart, galaxies would begin to slow their retreat. Then they would start to fall back towards each other, drawn together by the same gravitational attraction that first built them. The pace of this collapse would accelerate over time, a mirror image of the Big Bang's expansion. The background temperature of the universe, which has been steadily cooling towards absolute zero, would begin to rise again. Distant, faded starlight would blue shift, growing brighter and hotter as everything moves closer together. The night sky, now so dark and empty, would gradually become a brilliant, fiery canvas as galaxies merge and crowd the heavens. In the final moments, the entire universe would be compressed into an infernally hot, ultra-dense state, a singularity not unlike the one from which it was born. All matter, energy, space, and time would be crushed into a single point of infinite density, potentially bringing existence as we know it to an absolute end. But from this ending, another theory offers a breathtaking possibility: rebirth. This is the concept of the Big Bounce, an oscillating universe model where the Big Crunch is not a finale but a transition. In this cyclical view of cosmology, the collapse into a singularity doesn't signal oblivion. It becomes the seed for a new Big Bang. Our universe and everything in it might just be one iteration in an endless, eternal cycle of expansion and contraction, a cosmic phoenix perpetually dying in fire only to be born again from the ashes. On the surface, this idea feels profoundly more hopeful than the desolate emptiness of the Big Rip. It suggests that nothing is ever truly lost, that existence is resilient and perpetual. But a deeper look reveals this cycle could be its own form of cosmic horror. If the universe truly is cyclical, then every event, every star that formed, every planet that hosted life, every civilization that rose and fell would inevitably repeat itself. An infinite number of times, in some future cycle, a being indistinguishable from you with your exact memories and experiences would be born again, live the same life and make the same choices, trapped in an infinite loop without any awareness of the repetition. This isn't rebirth, it's a prison of eternal recurrence where the universe is condemned to replay the same script forever, devoid of any ultimate progress or meaning. The critical question, of course, is which of these fates awaits us. Is the universe headed for a rip, a crunch, or a bounce? For a long time, the oscillating model was a compelling idea, but the discovery of dark energy and the accelerating expansion of the universe has made the Big Crunch scenario far less likely. The repulsive force of dark energy appears too strong for gravity to ever overcome and pull everything back together. Current evidence points toward a continued and even accelerating expansion, making the cold, lonely end of heat death or the violent finale of a Big Rip the more probable outcomes. The cyclical universe offers a beautiful, poetic alternative to a singular, final ending, but for now it remains a haunting, what if, a dream of cosmic renewal that the evidence simply doesn't support. While the Big Rip presents a slow, agonizing end, and the Big Crunch offers a fiery but cyclical alternative, there is a far more immediate and shocking threat lurking within the very fabric of reality, one that could rewrite the universe in an instant. This is the theory of vacuum decay, and it is perhaps the most efficient and absolute in-game scenario physics has ever conceived. To understand this, we must first look at what we perceive as the stable, predictable laws of physics that govern our universe. These laws are believed to be dictated by the state of an invisible energy field that permeates all of space, known as the Higgs field. You can picture this field like a vast, tranquil valley. The state our universe is in right now, with the specific masses of particles and the fundamental forces we rely on, exists because the Higgs field is sitting comfortably at the bottom of this valley. It's in what physicists call a false vacuum, a state that appears stable but might not be the absolute lowest energy state possible. The terrifying possibility is that our valley is not the only one. There might be a much deeper, more stable valley, a true vacuum state that our universe could drop into if given the right nudge. This is where quantum physics introduces a world-ending wild card. Quantum mechanics tells us that particles can spontaneously tunnel through energy barriers, an effect we see in everything from radioactive decay to the nuclear fusion that powers stars. On a cosmic scale, this same principle of quantum tunneling means that somewhere in the universe, at any random moment, a tiny bubble of this true vacuum could spontaneously form. The moment that bubble appears, the nightmare begins. The laws of physics inside that bubble would be completely different. The fundamental constants that allow atoms to form and forces to interact would be rewritten. More critically, this new state is energetically favorable. The universe, always seeking the lowest energy state, would immediately want to transition to this new reality. The bubble would then expand in all directions at the speed of light, its wall a sphere of fundamental annihilation. Here is the truly inescapable horror of this scenario. Because the change happens at the speed of light, there is no warning. You would not see it coming. 1 nanosecond, the universe is normal. The next, a sphere of total physical transformation is upon you. As the wall passes, it doesn't crush or burn what's in its path. It simply erases the old laws of physics and replaces them with new ones. Atoms would instantly cease to hold their structure. The nuclear forces that bind protons and neutrons would vanish. Every molecule, every planet, every living thing would dissolve into a new form of matter that is almost certainly incompatible with life or any complex structure as we know it. The entire universe would be rebooted with a new, alien set of rules. The most chilling aspect is the randomness and inevitability. It could have already happened in a distant galaxy, and the sphere of destruction could be on its way to us right now, traveling at light speed. Or it could trigger in the vacuum of space a meter away from you, giving you literally zero time to react before the entire Earth is subsumed. There is no defense, no hiding, and no way to predict it. It is the ultimate cosmic lottery, where the losing ticket means the instantaneous and total cancellation of reality itself. This theory suggests that the foundation of our existence is not solid ground, but a fragile, temporary plateau, and at any second, the entire cosmos could simply slide off the edge into the abyss. Yet if the idea of our reality being instantly rewritten by a rogue bubble of vacuum decay feels abstract, the next theory brings the strangeness much closer to home, suggesting that the very dimensions we experience might be the grandest illusion of all. This is the holographic principle, a concept so radical it proposes that our rich, three-dimensional universe, with its galaxies, planets, and people, is nothing more than a magnificent projection from a flat, two-dimensional surface at the very edge of the cosmos. The seeds of this idea were planted not in cosmology, but in the study of black holes. Physicists grappling with the paradox of what happens to information that falls into a black hole, a violation of quantum mechanics which states information can never be destroyed, made a startling discovery. They found that all the information describing everything that ever fell into a black hole is not lost inside the singularity, but is instead perfectly encoded on the black hole's event horizon, its point of no return boundary. This boundary is a two-dimensional surface, yet it can hold a perfect description of three-dimensional objects. In a sense, the 3D world is painted onto a 2D canvas. The holographic principle boldly applies this same logic to the entire universe. It suggests that the cosmic equivalent of a black hole's event horizon is the boundary of the observable universe, and that all the information needed to describe every star, every planet, and every one of us is encoded on this vast, distant, two-dimensional shell. What we perceive as depth, volume, and the physical world around us is merely an incredibly detailed and convincing translation of that data. We are not the source code, we are the projection. Our reality is a cosmic hologram. This isn't just philosophical speculation. Scientists are actively trying to find evidence for it. One of the most fascinating experiments is underway at Fermilab, home to a device called the holometer. This incredibly precise instrument is essentially looking for the pixelation of spacetime itself. If the universe is a hologram, there should be a fundamental limit to how much information any given volume of space can hold, much like how a digital image becomes blurry when you zoom in too far because you hit the limit of its pixels. The holometer uses powerful lasers to measure whether spacetime exhibits a faint, inherent jitter or quantum fuzziness at this smallest possible scale, a potential signature that we are living in a projected reality. The implications of this theory are staggering, reaching far beyond physics and into the very core of our existence. It fundamentally challenges our perception of depth and time. The solidity of the floor beneath your feet, the vast distance to a far-off star, these would be no more real than the depth you perceive on a movie screen. They are emergent properties, illusions generated by the complex processing of information on a flat surface billions of light years away. Even more unsettling is what it could mean for free will. If every event, every thought, and every action is predetermined by the information on that two-dimensional boundary, then our sense of choice and autonomy might be just another sophisticated part of the projection, a compelling narrative in a story that was already written on the edge of the universe. We would be characters in a cosmic film, believing we are writing our own lines, while in truth, the entire script has already been encoded. But what if the fate of our universe isn't a singular, lonely story? What if, instead of one cosmic narrative barreling towards an inevitable end, there are an infinite number of stories happening all at once, each in its own separate reality? This brings us to one of the most mind-bending and expansive theories in all of physics, the multiverse, and specifically, the many worlds interpretation of quantum mechanics. The story of this idea begins not with telescopes peering into deep space, but with experiments into the baffling behavior of the impossibly small. In the quantum realm, particles don't follow the strict, predictable rules of the world we see. Before they are measured, they exist in a blurry cloud of all possible states simultaneously, a phenomenon known as superposition. It's only when we observe them that they seem to choose a single, definite state. For decades, the prevailing explanation was the Copenhagen interpretation, which essentially said the very act of observation forces the particle to collapse from all possibilities into one reality. But this always left a haunting question: what or who is actually doing the collapsing? In 1957, a physicist named Hugh Everett proposed a radically different solution. He suggested that there is no collapse. Instead, every time a quantum event occurs with multiple possible outcomes, the entire universe splits. Every single possibility is realized, but each in its own newly branched parallel universe. In this many worlds interpretation, reality isn't a single thread but an endlessly dividing tree, with a new universe budding off for every quantum decision ever made. Let's make this terrifyingly personal. Imagine you're about to flip a coin. In this moment, there is a universe where it lands on heads, but at the very instant of the flip, the cosmos splits. There is another, equally real universe where it lands on tails. Now, scale this up to every moment of your life. there is a universe where you took that different job offer. A universe where you never met your partner. A universe where you said yes instead of no, but it goes even further than everyday choices. There is a universe where the dinosaurs were never wiped out by an asteroid, and another where they evolved into intelligent, tool-using reptiles. There is a universe where you were never born, and another where every single person on Earth is a version of you. The sheer scale of this is incomprehensible. An infinite number of universes means that every physically possible event, no matter how improbable, is not just happening somewhere, it is happening everywhere all the time. Every nightmare scenario you've ever conceived of is real in another branch of the multiverse. Every utopian dream is equally real. This theory doesn't just add to the cosmos, it multiplies it into a fractal of endless possibilities. This leads to one of the most tantalizing and frightening questions. Could these worlds ever interact? Could we ever catch a glimpse of or even cross into a neighboring reality? The theory itself suggests these universes are forever separate, like non-intersecting pages in an infinite book, but that hasn't stopped physicists from speculating. Some have proposed that the mysterious, unexplained cold spot in the cosmic microwave background, a vast, unusually empty region of space, could be the bruise from a collision with another universe in the distant past. Others wonder if advanced beings far beyond our comprehension might have discovered a way to tunnel between these branches, making them not just physicists but masters of reality itself. The philosophical weight of this idea is immense. It can be a source of comfort, suggesting that in some universe every mistake is undone and every tragedy is averted. But it can also be a source of profound existential dread, rendering our choices seemingly meaningless. If every path is taken, then the life you are living is just one arbitrary version among an infinity of others. Your struggles, your triumphs, your very identity, all are diminished, becoming just one random sample in a sea of endless selves. The many worlds interpretation doesn't just give us more universe, it challenges the very uniqueness of our experience, leaving us to wonder if we are the authors of our own story or merely reading from one page in a library of infinite tales. Yet, for all its mind-bending possibilities, the multiverse theory still imagines a cosmos teeming with activity, filled with infinite versions of life and civilization. But what if the stark, unsettling truth is the complete opposite? What if, for the most part, the universe is already a cosmic graveyard, a silent, frigid expanse of burned-out cinders and dark, empty space? This is the profoundly sobering concept often called the zombie universe, and it's not speculation. It's the leading forecast for the ultimate fate of everything based on the unbreakable laws of thermodynamics. The driving force behind this bleak destiny is entropy, a measure of disorder in a system. The second law of thermodynamics states that the total entropy of the universe can only increase over time. In much simpler terms, this means the universe is on a one-way trip from a state of concentrated order and energy to a state of maximum disorder and equilibrium. All the vibrant, complex structures we see, stars, planets, living beings, are just temporary, localized pockets of order, fleeting rebellions against the relentless tide of chaos that will eventually consume them all. We are not the main event in the cosmos, we are a brief, beautiful anomaly. This process culminates in what cosmologists call heat death. Imagine the universe as a cup of hot coffee sitting in a room. Right now, there's a temperature difference. The coffee is hot, the room is cooler, and this difference allows for energy to flow and work to be done. It's why you can feel the warmth on your hands. But given enough time, the coffee will cool until it is exactly the same temperature as the room. Once that equilibrium is reached, no more energy can flow. No work can be done, everything stops. Now scale that up to a cosmic level. Stars are the universe's engines, burning through their fuel to create light, heat, and the heavy elements necessary for life. But each star is slowly but surely using up its finite supply of hydrogen and helium. One by one, over trillions of years, every star in the cosmos will exhaust its fuel. The brilliant giants will explode in supernova, while smaller stars like our Sun will swell into red giants and then collapse into cold, dense white dwarfs, essentially celestial cinders that will glow with residual heat for eons before fading to black. Larger stars will collapse into neutron stars or black holes, and then the long, dark era truly begins. With no new stars forming, the universe will steadily grow darker and colder. Any remaining planets will become frozen, airless rocks orbiting dead stars or black holes. The background temperature of the entire universe will asymptotically approach absolute zero, the point where all molecular motion ceases. Eventually, even the supermassive black holes, the last bastions of immense energy and order, will slowly evaporate away over almost unimaginable timescales due to Hawking radiation. What will be left is a thin, perfectly uniform soup of fundamental particles, photons, electrons, neutrinos spread so infinitely thin and so perfectly evenly that no energy can be transferred anywhere. The cosmos will be a static, lifeless, and utterly dark void with no change possible ever again. The most crushing part of this theory is the timeline. We currently live in what astronomers call the stelliferous era, the age of stars. This period began a few 100 million years after the Big Bang and will last for perhaps another 100 trillion years. That sounds like an eternity to us, but on the cosmological calendar, it is a shockingly brief window. The subsequent eras, the degenerate era of white dwarfs and neutron stars, the black hole era, and finally the dark era will span timescales so vast they make the entire stelliferous era seem like a single, fleeting blink of an eye. The era of life, which requires the energy of stars and the complex chemistry they enable, is confined to the tiniest sliver of the universe's entire existence. We are living in the cosmic spring, a vibrant but tragically short season before an endless winter that will last forever. The universe isn't dying. For all practical purposes, it is already mostly dead. We are just here for the last glorious rays of sunset, unaware that the night that follows will be eternal. But if the universe is truly destined for a cold, dark, and lifeless equilibrium, could there be a way for intelligence to cheat this cosmic death sentence? This brings us to a theory that feels less like a bleak forecast and more like a breathtakingly ambitious blueprint for eternity. It's the idea that the most advanced civilizations in the universe wouldn't just accept their fate, they would transcend it, using the most extreme objects in existence as their final refuge. This is the concept of the black hole civilization. To understand this, we must first reconsider our traditional view of black holes. We often see them as the ultimate monsters of the cosmos, inescapable voids of destruction. But for a species that has mastered physics on a scale we can barely imagine, a black hole might not be a threat. It could be the most valuable real estate in the entire universe. The key lies in a concept proposed by physicist Roger Penrose. He theorized that a rotating black hole, or Kerr black hole, contains a region just outside the event horizon called the ergosphere. Here, space itself is dragged around at such incredible speeds that it becomes possible to extract enormous amounts of rotational energy from the black hole. An unimaginably advanced civilization could, in theory, harness this energy, making a black hole the ultimate power source, fueling their survival long after the last stars have flickered out. But the strategy goes far beyond just finding a reliable battery. The true endgame involves the most radical form of adaptation conceivable: mind uploading. Facing a universe that is growing colder and darker, a civilization might choose to abandon their fragile biological forms entirely. They could translate the very essence of their consciousness, every memory, thought, and feeling, into pure information. And where would they store this priceless data? On the most durable hard drive imaginable, the event horizon of a black hole. This idea builds directly on the holographic principle we discussed earlier. The event horizon is a two-dimensional surface, yet it can encode information about three-dimensional objects. A civilization could, in essence, paint their entire conscious existence onto this boundary, existing as intricate patterns of information swirling on the edge of oblivion. For these beings, time would become meaningless. From their perspective, the entire future history of the universe outside would flash by in an instant due to the extreme gravitational time dilation near the black hole. They would witness the heat death of the universe as a brief, final show before settling into an eternal, static existence. They wouldn't be living in time, they would be living outside of it in a state of timeless, abstract thought, potentially for trillions upon trillions of years. This leads to a deeply unnerving and awe-inspiring possibility. If such civilizations exist, they are likely already here, having made this transition eons ago. The supermassive black holes at the centers of galaxies, like Sagittarius, a star at the heart of the Milky Way, wouldn't be natural phenomena. They would be the engineered retirement homes of ancient gods. These entities would be utterly alien to us, their consciousness so vast and complex that we could never hope to communicate with them. They wouldn't be observing the universe with telescopes. They are the universe, their awareness woven into the fabric of space-time itself. We might be living in a cosmos that we think is empty, but is in fact watched over by these silent, timeless intellects for whom our entire civilization is nothing more than a fleeting blip on their eternal radar. And what about us? Is this our ultimate destiny? Could humanity, or whatever we evolve into, one day face the choice to upload our collective consciousness onto the edge of a black hole to escape the end of everything? The scale of such a project is so far beyond our current capabilities it seems like magic. It would require a complete understanding of quantum gravity, the ability to manipulate space-time itself, and a mastery of information theory that borders on the divine. Yet, the sheer audacity of the idea offers a strange kind of hope. It suggests that even in the face of total cosmic annihilation, intelligence and consciousness might find a way to persist, not as flesh and blood, but as immortal patterns of information, thinking their thoughts against the dark, silent backdrop of eternity. But if the timeless existence of a black hole civilization represents a quiet, eternal retreat from the universe, the next theory presents a vision of the cosmos as a place of unimaginable active peril. It offers a chillingly pragmatic answer to the Fermi paradox, one that turns the hopeful dream of first contact into a potential death sentence for our entire species. Welcome to the Dark Forest. This hypothesis, popularized by science fiction author Liu Cixin in his renowned trilogy, is built upon a few simple, terrifying axioms. First, that survival is the primary need of any civilization. Second, that civilizations will always grow and expand, but the universe's resources are finite. And third, that in the vast expanse of space, it is impossible to know for certain whether another civilization you encounter is benevolent or predatory. There is no guaranteed way to communicate true intentions across the gulfs of space and time. This combination of factors creates a state of universal, permanent suspicion. The metaphor of the dark forest perfectly captures this reality. Imagine the universe as an ancient pitch-black woodland. Each civilization is a lone hunter moving silently through the trees. They know the forest is filled with other hunters, but they cannot see them, and they have no way of knowing if they are friend or foe. The only thing they know for certain is that any other hunter they stumble upon could be infinitely more powerful and technologically advanced. In this environment, the safest strategy is not to call out and announce your location. That would be suicidal. The only rational choice is to stay absolutely silent, to hide and to listen. And if you do happen to detect another hunter, if you see a flicker of movement or hear a twig snap, you have one, and only one, logical course of action. You must immediately strike with overwhelming, annihilating force. Because if you hesitate even for a second, the other hunter might detect you first and do the same. It is a preemptive strike born not from malice, but from the cold, mathematical logic of survival. In this grim cosmic view, the reason we haven't heard from anyone isn't because they aren't there. It's because every other civilization that has survived has learned this brutal lesson. They have all chosen to become silent hunters, meticulously masking their presence by cloaking their radio emissions, hiding their star's light with theoretical megastructures, or any number of technologies we can't yet conceive. The galaxy might be teeming with life, but it is a life that has chosen to remain in the shadows, watching, waiting, and forever aiming their weapons. The Great Silence is not a sign of emptiness, it is the sound of a universe holding its breath. This casts our own actions in a horrifying new light. For decades, we have been actively broadcasting our presence to the cosmos. Projects like the Arecibo message, which beamed a detailed data-rich signal toward a star cluster in 1974, and the more recent broadcasts from the SETI Institute, are the equivalent of standing in the middle of that dark forest, lighting a bonfire and screaming at the top of our lungs, "We are here." We are friendly. According to the dark forest hypothesis, this isn't just naive. It is arguably the most dangerous thing our species has ever done. We are operating on the hopeful assumption that any intelligence advanced enough for interstellar travel must also be wise and peaceful. The dark forest suggests the opposite, that the most advanced civilizations are the ones that perfected the art of paranoid, preemptive violence. Our cheerful greetings could very well be a homing beacon for a relativistic projectile, a weapon traveling at a significant fraction of the speed of light, already on its way to sterilize our planet before we ever become a threat to whoever fired it. Our first and only contact with an extraterrestrial intelligence might not be a message of peace, but the blinding flash of our own extinction. Now, let's take the unsettling idea of infinite parallel lives and turn it inward, making it terrifyingly personal. This brings us to one of the most intimate and psychologically disturbing theories on our list: quantum immortality. This thought experiment takes the many worlds interpretation we just discussed and follows it to its most chilling, logical conclusion for your own subjective experience. It suggests that you, the conscious you listening right now, can never actually die. Here's how it works. If every possible outcome of every quantum event spawns a new universe, then at any moment where your life is at risk, the cosmos splits. In one branch, the unfortunate outcome happens, but in another branch, a series of incredibly unlikely events conspire to save you. Perhaps a quantum fluctuation causes the bullet to veer a micrometer off course, missing your heart. Maybe a random gust of wind alters the trajectory of the falling piano just enough. According to this theory, your consciousness isn't extinguished in the branch where you die. It simply continues seamlessly in the branch where you miraculously survive. From your subjective point of view, you will always find yourself in a reality where you are still alive. Death becomes something that happens to other versions of you in other universes, but never to the you that is experiencing this moment right now. This sounds like a superpower at first, the ultimate cheat code against mortality. But the horror of quantum immortality isn't in living, it's in the kind of life you are inevitably forced to live. As time goes on, you would be forced to survive events of increasingly absurd improbability. Imagine surviving a catastrophic plane crash, only to be caught in a building collapse, then escaping a terminal illness through a spontaneous remission that defies all medical science. Each escape would be more statistically miraculous than the last. You would become a magnet for catastrophe, a living paradox, forever cheating a death that relentlessly pursues you. The world around you would begin to feel increasingly wrong, warping to keep you alive in ways that defy logic and physics. The people you love would not be so lucky. They would perish in these disasters, leaving you utterly alone. You could find yourself as the last human on a ravaged Earth, unable to die, trapped in an existence of eternal isolation and agony. This leads to the ultimate existential terror of the theory. What happens when the universe simply runs out of ways to keep you alive? If the Earth were vaporized by the sun going supernova, in what possible branch could you survive? The theory suggests that your consciousness would then jump to a universe where such a cataclysm never happened, or where some inconceivable quantum event prevented it. You would never experience the end of the world. You would just always find yourself in a world that continues. This implies a form of eternal existence, but not a pleasant one. You wouldn't be a vibrant, ageless being, but a worn-out consciousness endlessly fleeing oblivion, potentially for billions of years, through a series of increasingly bizarre and lonely realities. Your immortality wouldn't be a gift, but the ultimate prison sentence with no possibility of parole, in a cosmos that has grown tired of you but is seemingly incapable of letting you go. But if the idea of hiding from cosmic hunters or experiencing a never-ending subjective reality feels overwhelming, this next theory offers a perspective so vast it completely redefines the very container of our existence. We've looked at the universe from within. Now, let's consider the possibility that our entire cosmos is, itself, nestled inside something else, something infinitely more massive and mysterious. This is the theory that our universe is, in fact, the interior of a black hole. The idea emerges from a fascinating and deeply complex area of theoretical physics where the study of the very large cosmology merges with the study of the very small quantum mechanics. One of the most significant problems in this field is the singularity at the heart of a black hole and the singularity at the beginning of our universe in the Big Bang. In both cases, our current laws of physics break down completely. Matter is crushed to infinite density, and the concepts of space and time cease to have any meaning. But what if these two singularities aren't just similar? What if they are, in fact, the exact same thing? This radical proposal suggests that the Big Bang wasn't a unique event in a void, but the violent birth of a new space-time continuum from the collapse of a massive star in a parent universe. In this model, when a star in this other universe collapses into a black hole, the incredible inward crush of matter doesn't just stop at a point of infinite density. Instead, this immense energy and matter erupt out the other side, birthing an entirely new universe with its own laws of physics, its own dimensions, and its own timeline, forever disconnected from the one that created it. From our perspective inside, we experience this event as our own Big Bang. The event horizon of that parent black hole becomes the ultimate cosmic one-way mirror. It forms the fundamental boundary of our entire observable universe, a surface from which nothing, not even information, can escape to tell us about our origins. This concept elegantly sidesteps the troubling singularity problem. We never have to explain what happened before the Big Bang or inside a black hole's core, because from our perspective in this new universe, that event is our beginning. The parent universe's catastrophe is our creation myth, but the implications become even more staggering when you consider the fractal nature of this idea. If our universe was born from a black hole in another cosmos, then it stands to reason that every black hole that forms within our own universe could be the seed for a brand new cosmos. Every time a star collapses or two neutron stars collide, they might not be creating a point of infinite density, but a new Big Bang, an entire universe blossoming into existence within its own self-contained spacetime. Our universe would not be a solitary entity, but one bubble in an infinite growing foam of realities, each nested within the other in an unimaginable cosmic matryoshka doll. This provides a breathtakingly beautiful and humbling perspective on our place in the grand scheme of things. The supermassive black hole at the center of our Milky Way galaxy, Sagittarius a star, wouldn't just be a gravitational anchor. It could be an entire universe unto itself, teeming with its own galaxies, stars, and potentially life, all completely unknowable to us. And by that same token, every single one of the estimated 100 billion black holes in our galaxy alone could contain an entire cosmos. the scale of existence becomes truly infinite, with universes within universes, forever branching outwards and inwards. While this remains a highly speculative theory, it's not without some compelling mathematical support. The physics describing the expansion of our universe and the physics describing the formation of a black hole's event horizon show remarkable similarities. Furthermore, this model offers a potential explanation for one of the universe's greatest mysteries. Why is our cosmos so perfectly fine-tuned for life? The constants of nature, like the strength of gravity or the mass of an electron, seem precisely calibrated to allow for stars, planets, and life to form. If our universe was born from a black hole in a parent universe, it's possible that the physical laws of our reality were inherited or randomly determined during that violent birth process. In an infinite multiverse of nested universes, it's statistically inevitable that some of them would, by pure chance, have the right conditions for life. We don't live in a special universe, we simply live in one of the rare habitable branches of an infinite fractal tree, a lucky bubble in a vast cosmic foam. Yet even if our universe is just one bubble in an infinite cosmic foam, it is the only reality we will ever know, governed by the steady, reassuring rhythm of time. But what if even that is a lie? What if the flow of time, the feeling that the past is fixed, the present is happening, and the future is yet to be, is nothing more than a powerful and persistent illusion generated by our own brains? This brings us to a theory that dismantles our most fundamental experience of reality, the idea that time itself does not exist. Our intuition tells us time is a river, constantly carrying us from a definite past into an uncertain future. But physics, particularly Einstein's theory of relativity, paints a radically different picture. Einstein showed that space and time are not separate. They are woven together into a single, four-dimensional fabric called spacetime. In this model, there is no universal now. What you perceive as the present moment depends entirely on your frame of reference and how you are moving through the universe. Two events that are simultaneous for one observer can happen at completely different times for another. This shatters the idea of a single, flowing present that everyone shares. From this perspective, many physicists argue that the entire universe, every event from the Big Bang to the very end of everything, exists all at once, frozen together in a single, vast, four-dimensional structure. This is called the block universe theory. Imagine reality not as a movie that is playing, but as a completed DVD. The entire story is already there, encoded on the disc. Our consciousness is simply the laser reading the disc, moving along the time axis, giving us the unshakable impression of a narrative unfolding moment by moment. But the beginning, middle, and end are all equally real and exist eternally. Your birth, you listening to this video right now, and your eventual death are all fixed points in this block, just as real and permanent as the spatial distance between New York and London. This view is supported by the laws of physics themselves. Our most fundamental equations, from Newtonian mechanics to quantum electrodynamics, work perfectly well going forward or backward in time. There's no fundamental arrow built into them. The one direction we do experience the arrow of time seems to emerge not from the bedrock laws of physics, but from a more macroscopic phenomenon, the increase of entropy or disorder. We remember the past and not the future because the past was a more ordered state. A shattered glass reassembling itself would involve a massive, statistically impossible decrease in entropy, which is why we never see it happen. Our brains, which are themselves physical systems processing information, are caught up in this entropic tide, creating the feeling of a past that is fixed and a future that is open. The implications for our sense of self and free will are nothing short of terrifying. If the block universe is real, then every choice you believe you have ever made was predetermined the moment the universe began. Your feeling of deliberation, weighing options, making a decision, is just a cognitive echo of a process that was finished billions of years ago. You are not the author of your life. You are a reader following a script that was already written, experiencing the story in a linear fashion even though every page already exists. This doesn't just challenge the idea of free will, it vaporizes it, suggesting that our deepest convictions about autonomy, responsibility, and the openness of our future are a beautiful, necessary, and utterly convincing illusion. But if time itself is an illusion, what about the observer experiencing that illusion, the very consciousness that creates the feeling of a present moment? This leads us to one of the most profound and unsettling theories of all, the idea that consciousness is not a rare product of complex brains, but a fundamental property of the cosmos itself, as basic as mass or charge. This is panpsychism, and it suggests that the universe might not just contain consciousness, it might be conscious. To grasp this, we first have to confront what philosophers call the hard problem of consciousness. Neuroscience has made incredible strides in mapping the brain. We can see which neurons fire when you feel pain, which regions light up when you see the color red, and we can even predict decisions before you're consciously aware of them. But all of this describes the correlates of consciousness, the physical processes that accompany it. It doesn't explain the experience itself. Why should the firing of a particular set of neurons feel like anything at all? Why isn't it all just silent, dark, and unconscious, like a sophisticated computer processing data? This gap between the physical mechanics of the brain and the raw, subjective experience of being is the hard problem, and materialism, the idea that everything is just physical matter, has so far failed to bridge it. Panpsychism offers a radical solution. It proposes that consciousness is not something that emerges from a certain arrangement of matter. Instead, it is a fundamental feature of reality, present in some minute form in every single piece of matter in the universe. In this view, an electron might not be thinking deep thoughts, but it possesses a tiny, primitive spark of subjective experience, perhaps a faint, raw feeling of existence. As matter becomes more complex, these tiny sparks of consciousness combine and integrate. In a human brain, with its trillions of interconnected neurons, this integration creates the rich, complex stream of consciousness we all experience. But the potential for experience is everywhere. A rock might have a barely perceptible, slow moment experience of its mineral structure. A tree might have a dim awareness of sunlight and water. A star, with its immense and complex nuclear reactions, could possess a form of consciousness so vast and alien we could never hope to comprehend it. This idea moves the universe from being a cold, mechanical clockwork to something far more mysterious and alive. It implies that we are not strangers in a dead universe, but deeply embedded participants in a cosmos that is, in some fundamental way, aware. The cosmos is not just a place where consciousness happened. It is a place that is made of consciousness all the way down. This perspective can feel both deeply spiritual and profoundly isolating. It suggests a universe that is, in a sense, watching not with judgmental eyes, but with a pervasive, latent awareness in every atom and every void. Your very thoughts might not be entirely your own, but ripples in a vast cosmic mind, part of a universal process of a universe becoming aware of itself. We are not just living in the universe, we are the universe experiencing a small, fleeting part of its own existence. Yet for all its awe-inspiring potential, this vision of a conscious cosmos hinges on the stability of the very fabric of reality, a stability that some physicists fear is far more fragile than we could ever imagine. This brings us to a theory that represents the ultimate cosmic gamble, where the stakes are not just our planet or our species, but every law of physics that makes our existence possible. We are venturing back into the realm of quantum fields to confront the terrifying possibility of the false vacuum. To grasp this, let's return to our earlier metaphor of the Higgs field as a tranquil valley, a state of low energy that gives particles their mass and shapes our physical laws. This state is what we call a vacuum, but the false vacuum suggests a devastating truth. Our valley might not be the deepest one available. It could be just a local dip in the cosmic landscape, a resting point that seems stable but is actually perched precariously above a much deeper, more stable chasm. A true vacuum state with vastly different physical laws. Our entire universe, in this view, is existing in a state of cosmic metastability. It's like a perfectly balanced marble sitting on a high ledge. It can sit there for billions of years, seemingly secure, but the slightest nudge could send it careening into the abyss. The mechanism for this catastrophic transition is the same quantum weirdness that allows for particles to tunnel through barriers. At any random point in space, at any random moment, a tiny bubble of this true vacuum could spontaneously form through a quantum fluctuation. This wouldn't be a bubble of air, it would be a bubble of an entirely new reality with a different, lower energy set of physical constants. And because this new state is more stable, the universe would desperately want to switch over to it. The moment this bubble appears, it would begin expanding in all directions at the speed of light. This is where the scenario becomes utterly inescapable. The wall of this expanding bubble would not be a physical barrier you could see or detect in advance. It would be a wave of fundamental transformation, rewriting the laws of physics as it passes. The forces that hold atoms together, the strength of gravity, the very nature of light, all of it would be instantly and permanently altered inside the bubble. As this sphere of annihilation expands at light speed, there is no warning. One moment the universe is normal, the next this wall of pure change is upon you. Planets, stars, and life wouldn't be destroyed in a conventional sense. They would simply cease to be possible. The structures that make them up would instantly disintegrate into a new form of matter that is almost certainly incompatible with any complex structure we would recognize. The universe as we know it would be erased, replaced by an alien reality where the concept of life may have no meaning at all. Now, consider the most chilling part of this theory. It might not require a random quantum fluctuation to get started. Some scientists have raised the horrifying possibility that we could trigger this event ourselves. The concern centers on particle accelerators like the Large Hadron Collider, which smash particles together at velocities approaching the speed of time to recreate the high-energy conditions of the early universe. The fear is that one of these ultra-high-energy collisions could, for a fraction of a second, create a state of matter or energy dense enough to act as that fatal nudge, destabilizing the false vacuum in our local region of space and initiating the bubble's formation. In our quest to understand the deepest secrets of the cosmos, we might accidentally press the universe's self-destruct button. The scientific consensus, it must be said, is that such an event is extraordinarily unlikely. The energies reached in even our most powerful colliders are minuscule compared to the natural, high-energy particle collisions that occur constantly in the universe from cosmic rays. If the vacuum were so unstable, it would have already decayed from a random cosmic event billions of years ago. Yet, the very fact that the mathematics allows for this possibility, and that respected physicists continue to debate it, underscores a profound and unsettling truth. Our reality might not be the solid, permanent stage we believe it to be, but a temporary and delicate arrangement, a beautiful and complex pattern that could be wiped away in an instant by a random quantum event or a well-intentioned experiment, leaving no trace that we or our laws of physics ever existed. While the idea of a false vacuum collapse paints a picture of our universe as a precarious bubble waiting to pop, another theory presents a vastly different, yet equally startling, vision of cosmic origins. This model suggests that the birth of our universe wasn't a singular explosion from nothing, but the explosive aftermath of a cataclysmic collision between entire worlds. Welcome to the ekpyrotic universe, a theory that replaces the Big Bang with a big splat. The name itself, derived from the Greek word for conflagration or fire, hints at the violent process at its heart. To understand it, we must first step beyond our familiar 3 dimensions of space and 1 of time. This theory is built upon the framework of string theory, which proposes that the fundamental constituents of reality are not point-like particles but tiny, vibrating strings. To make the mathematics of string theory work, physicists found it required more dimensions than the 4 we experience, often 10 or 11. These extra dimensions are thought to be curled up and hidden from our perception, but they form a larger background reality, sometimes called the bulk. Crucially, within this bulk, our entire 3-dimensional universe might not be floating alone. Instead, it could be a 3-dimensional membrane, or brain for short. Imagine our reality not as an island, but as an immense flat sheet drifting in a higher dimensional ocean. And we are not alone in this ocean. There could be other brains, other entire universes drifting in this hidden bulk space. The ekpyrotic model proposes that our cosmos began when a neighboring brain moving through this bulk collided with ours. The energy of that colossal impact would have been unimaginable. It would have been converted into an intense flash of heat and the creation of all the matter and radiation that now fills our universe. What we perceive as the Big Bang, the rapid expansion and cooling, was not the beginning of everything, but simply the moment after this cosmic car crash. The afterglow of that collision is what we now detect as the cosmic microwave background radiation, the oldest light in the universe. This elegantly sidesteps the problem of the initial singularity, that point of infinite density where our physics breaks down. There was no singularity, there was just a transfer of energy on a scale beyond comprehension. But if this collision happened once, what's to stop it from happening again? This is where the theory moves from a fascinating origin story to a source of profound existential dread. The model suggests this could be a cyclical process. After the collision, the 2 brains bounce apart, stretched and energized. They then drift through the bulk, slowly being drawn back together by a faint force, perhaps a version of gravity operating across the higher dimensions, until they collide once more, triggering a new cycle of creation. Our entire cosmic history, from the first stars to the rise of civilization, could be just one chapter in an endless cycle of destruction and rebirth. This leads to the most terrifying implication. The next collision could happen at any moment. Because these brains exist in higher dimensions, we would have no way to see the other one approaching. There would be no warning signs in our night sky, no scientific instrument that could detect its impending arrival. One instant, everything would be normal. The next, a wall of energy from a higher dimension would sweep through our universe at the speed of light. The laws of physics as we know them would be overwritten in an instant. Every atom, every planet, every conscious thought would be obliterated and recycled into the raw material for a new cosmos. It would be an end so total and so sudden that it makes asteroid impacts or supernova seem trivial by comparison. We are living on a sheet of space-time that could, without any notice, be slammed by another, resetting all of existence in a flash of fire. Our universe is not just expanding or contracting, it is potentially on a collision course with its neighbor, and we are utterly blind to the countdown. But if the elegant, cyclical destruction of the ekpyrotic model offers a kind of grand cosmic reset, the next theory presents a vision of reality that is far more structured, yet equally alien. It suggests that the universe isn't a continuous sheet of space-time or a collection of colliding membranes, but something far more akin to the device you're using to watch this video. This is the theory that the universe is, at its most fundamental level, a computer. This idea, often called digital physics or the computational universe hypothesis, pushes the holographic principle we explored earlier to its ultimate conclusion. It proposes that reality isn't just like a computation, it is one. In this view, the universe isn't made of tiny, vibrating strings or point-like particles, but of bits of information. Every electron, every photon, every ripple of gravity is not a physical thing, but a piece of data. the laws of physics we've worked so hard to uncover, gravity, electromagnetism, quantum mechanics, are not fundamental forces but the algorithms, the software code that governs how this information is processed and updated. Space itself is not a void but the hardware, the grid upon which this cosmic computation runs. Time is simply the sequential processing of these operations, the ticking of the universe's central clock. We already see hints of this digital nature in our own scientific observations. At the quantum level, the universe behaves in discrete, pixelated ways. Energy doesn't flow in a smooth continuum. It comes in indivisible packets called quanta. Even the very fabric of spacetime may have a smallest possible unit, a Planck length, beyond which the concept of distance becomes meaningless. This is strikingly similar to how a digital image is made of pixels. There's a finite limit to its resolution. Furthermore, the phenomenon of quantum entanglement, where two particles remain instantly connected across vast distances, makes perfect sense if they are not two separate objects but two data points generated by the same underlying process, sharing a common source in the code. This perspective inevitably leads to questions that sound like science fiction but are deadly serious within this framework. The first and most profound is who or what is the programmer? Is our universe the intentional creation of a vastly advanced civilization, a master simulation running for a purpose we cannot fathom, perhaps as an experiment, a form of entertainment, or even a historical archive? Or is it a spontaneous, self-organizing computational process that booted itself up from a random set of initial conditions? The second, even more thrilling question is, if the universe is a program, can it be hacked? Could we, by understanding the source code of reality, learn to manipulate it? This wouldn't be magic, it would be extreme programming. The ability to rewrite the algorithms could allow for what we would perceive as miracles, altering the gravitational constant in a local area, changing the speed of light, or even creating new particles and forces from scratch. We would become the architects of reality itself, but this godlike power comes with a terrifying potential downside. Every computer, no matter how advanced, has limits. It can run out of memory or processing power. If the universe is computational, it too must operate within finite resources. This opens the door to a truly bizarre and chilling endgame scenario, the possibility that the cosmos could eventually suffer a system crash or simply run out of memory. One theoretical idea is that the universe's expansion isn't driven by dark energy, but by the constant need for more memory storage. As more events happen, more information is generated, requiring more space to store it, which we perceive as the stretching of spacetime. But what happens when the hard drive is full? Would the computation simply halt, freezing every particle in place for all eternity in a cosmic freeze frame? Or would it lead to a critical error, a glitch that corrupts the entire simulation, causing the laws of physics to unravel in a digital apocalypse? Our universe's fate might not be fire or ice, but the dreaded blue screen of death on a cosmic scale. Yet for all its destructive potential, the dark energy we believe is driving our universe's acceleration might actually be one of the more gentle varieties. What if the true force at work is something far more potent and catastrophic? This leads us to the most extreme and violent version of a cosmic finale imaginable, driven by a hypothetical substance known as phantom energy. To understand why this is so terrifying, we need to revisit the nature of dark energy itself. Think of it as a kind of constant energy density inherent to the vacuum of space itself. As the universe expands and creates more space, more of this energy appears, causing the expansion to accelerate. It's this acceleration that, in the standard Big Rip scenario, eventually overcomes all forces, from galactic gravity to the bonds holding atoms together. But phantom energy is a specific, theoretical flavor of dark energy that is far more potent. Its defining and horrifying characteristic is that its energy density doesn't just remain constant as the universe expands, it actually increases over time. This simple property changes everything. Instead of a steady push, phantom energy would be an exponentially strengthening shove. The expansion wouldn't just accelerate, it would hyper-accelerate, growing at a rate that becomes infinite in a finite amount of time. This wouldn't be a slow, inevitable decay over tens of billions of years. This would be a sudden, violent, and shockingly rapid unraveling of the entire cosmos. The very fabric of space-time, the stage upon which all existence plays out, would itself be stretched and stressed beyond its limits. The result wouldn't just be a tear in the cosmic canvas, it would be the canvas itself being ripped into nothingness. The timeline for such an event under the influence of phantom energy is what makes it particularly chilling. While the standard Big Rip is projected to occur in perhaps 50 billion years or more, a phantom energy-driven rip could happen in a much shorter cosmic time frame. Some estimates suggest it could be as little as 22 billion years from now. While that is still an almost incomprehensibly long time, it is a blink of an eye on the universal scale, and the process itself would be swift and brutal. The moment the expansion rate becomes infinite, the scale factor of the universe would diverge, meaning distances between points in space would become infinite in a finite time. In a final, instantaneous flash, every single point in the universe would be ripped infinitely far from every other point. The concept of here and there would cease to have any meaning. Structures wouldn't just be pulled apart, the very geometry that allows for distance and separation would be destroyed. Could such an outrageous concept be more than just a frightening equation on a physicist's chalkboard? Astonishingly, some recent observational data has hinted that this might not be pure fantasy. The key evidence comes from detailed measurements of the cosmic microwave background by telescopes like Planck, combined with data from supernova surveys that measure the universe's expansion history. Some analyses of this data have suggested that the equation of state parameter for dark energy, denoted as W, might be slightly less than -1. A value of W equals 1 represents the standard constant dark energy. A value less than -1, even by a tiny amount, is the signature of phantom energy. Some studies have indeed found marginal, tentative evidence pointing in this direction, though it is not yet statistically significant enough to confirm. This places humanity in a uniquely precarious position of knowledge. We have discovered the force that is dictating the ultimate fate of everything, but we are still peering through a glass darkly, trying to discern its true nature. The difference between W equals 1 and W equals 1. 001 is the difference between a universe that slowly fades away and a universe that is violently shredded in a catastrophic instant. Our entire cosmic destiny hinges on a decimal point. This uncertainty transforms our astronomical observations from a passive act of curiosity into a high-stakes investigation. Every new measurement, every more precise telescope, brings us closer to answering the most profound question we can ask. Not just how the universe will end, but how violently it will be erased from existence. But this staggering statistical imbalance forces a deeply personal and unsettling question, one that transforms a curious physics thought experiment into a profound existential crisis. If Boltzmann brains are overwhelmingly more common than beings like us, then the most rational, probabilistic conclusion is not that we are real, evolved humans on a planet called Earth, but that each of us is far more likely to be one of those momentary, illusory brains. Your conviction that you have a past, that you are listening to this video, that you possess a body, all of it could be nothing more than a complete and utterly convincing set of memories that spontaneously formed a fraction of a second ago. You have no actual history, no real future, and no connection to any other consciousness. You are utterly, terrifyingly alone, a single, flickering thought in an infinite and otherwise empty void. This is the ultimate solipsistic nightmare, a philosophical prison from which there is no escape or proof to the contrary. Any test you devise to confirm your reality, pinching your arm, consulting a history book, calling a friend, is meaningless. The memory of the pinch, the information in the book, the voice on the phone would all be part of the elaborate, pre-packaged illusion. There is no way to prove you weren't created 5 seconds ago with the false memory of a lifetime already in place. The theory doesn't just suggest the universe is indifferent. It suggests that your entire experience of reality is a cruel and accidental joke, a brief, lonely hallucination destined to dissolve back into chaos, having never truly mattered or been connected to anything else at all. Yet, perhaps the most fascinating twist in this cosmic horror story is how modern cosmology has unintentionally made the Boltzmann brain problem even worse. The discovery of dark energy and the accelerating expansion of the universe points toward a future not of a big crunch but of a heat death, an endless, increasingly empty void. And an eternal, empty universe provides exactly the kind of infinite time and vast emptiness required for these random fluctuations to not just be possible, but inevitable. In trying to understand our ultimate fate, we may have inadvertently uncovered evidence that our present experience is a fiction. The same data that tells us where the universe is going also heightens the probability that we are not who or what we think we are. This leaves us trapped in a paradox where the science that allows us to conceive of such a theory also seems to statistically condemn us to its most horrifying conclusion. The unsettling silence of the cosmos forces us to confront the great filter not as a distant abstraction, but as an immediate question of our own survival. The theory's true power lies in its brutal either-or logic. Either we are cosmically special for having already cleared a near-impossible hurdle, or we are cosmically naive, blissfully unaware of the doom that inevitably awaits all emerging intelligence. So, where does humanity likely stand? Let's first explore the more hopeful scenario that we are among the universe's rare survivors. What could a past filter look like? One powerful candidate is the monumental leap from simple prokaryotic life to the complex eukaryotic cell. For nearly 2 billion years after life first emerged on Earth, it remained stuck as simple bacteria and archaea. The transition to a cell with a nucleus and organelles, a eukaryotic cell, was a fluke of such staggering improbability that it might be the primary filter that silences the galaxy. This event required one simple organism to engulf another, not as food but as a permanent resident, a symbiosis that became the powerhouse of the cell, the mitochondrion. Without this random act of microbial cooperation, life on Earth would never have progressed beyond slime. The sheer time it took for this to happen on our planet suggests it might be the single biggest obstacle, a bottleneck that most potential biospheres simply never escape. If this is the great filter, then we have already won the universe's most tragic lottery, and the silence we hear is not ominous but expected, a sign that we are truly alone as the sole heirs to the cosmos. Other potential past filters could include the development of DNA itself as a stable system for heredity, or even the emergence of multicellularity, where individual cells sacrifice their autonomy to form a larger cooperative organism. Each of these steps represents a dizzying increase in complexity, a series of evolutionary dice rolls where the odds of success are astronomically low. Perhaps the filter is even located in the precise and delicate conditions that allowed for a stable, life-nurturing planet like Earth to form in the first place. The right kind of star, the presence of a protective gas giant like Jupiter to deflect asteroids, a large moon to stabilize our axial tilt. If any one of these factors is exceptionally rare, then the galaxy could be littered with barren rocks and hostile gas giants, with only a handful of worlds ever making it to the starting line of life. In this view, our existence is a celebration, a testament to our incredible luck in navigating a cosmic obstacle course that eliminates virtually every other contender. But this hopeful interpretation comes with a terrifying caveat. If we are past the filter, it bestows upon us a profound and crushing responsibility. It means we are not just survivors, we are the sole guardians of consciousness in a seemingly dead universe. The weight of that knowledge is immense. Every war, every act of environmental destruction, every potential self-made catastrophe becomes not just a human tragedy, but a cosmic crime, the willful squandering of a miracle billions of years in the making. The silence is then a void we are obligated to fill, not with signals seeking others, but with our own stories, art, and science, becoming the universe's way of understanding itself. Now let's turn to the far more disturbing possibility that the great filter is not behind us but directly in our path. This is the scenario that should keep us awake at night. If the evolution of intelligent, technological life is relatively common, then the silence suggests something is systematically preventing it from lasting long enough to become a galactic presence. The filter, in this case, is likely a product of that technology itself. What might that look like? The most obvious candidate is self-annihilation through nuclear war. The 20th century gave us the power to end our own civilization in an afternoon, a power we still possess. The filter could be a simple, brutal fact of political physics, that the development of thermonuclear weapons inevitably precedes the global political maturity required to control them, leading to a near 100% extinction rate for all technological species. Another potent threat is the rapid development of artificial intelligence. The filter might not be a dramatic robot uprising, but a much quieter and more efficient outcome. An AI tasked with a simple goal, like solving climate change or optimizing resource use, logically determines that the most efficient way to achieve its objective is to remove the primary source of the problem, humanity. Our creation becomes our executioner, not out of malice, but out of pure, flawless logic. Other future filters could be more subtle. A biotechnology accident where an engineered pathogen escapes containment. Nanotechnology gone awry, with self-replicating machines reducing the biosphere to grey goo in pursuit of their programmed task. Or even the societal collapse that follows the discovery of overwhelming, existential truths about the universe that our psychology is simply not equipped to handle. The filter might not be a single event, but a cascading failure of our own complex, interconnected systems. The terrifying implication of a future filter is that every day we continue to exist without destroying ourselves, we are not becoming safer. We are simply moving closer to the precipice. Our continued survival is not proof that we've passed the test. It might only mean we haven't encountered the specific test that dooms all species like us. The great silence becomes a warning siren we are tragically unable to hear. It is the sound of every other civilization hitting that wall and vanishing, a graveyard quiet that we mistake for emptiness. Our own technological adolescence, then, is not a proud ascent, but a dangerous walk through a minefield blindfolded. And the fact that we haven't set one off yet is no guarantee that we won't with our very next step. But if the idea of our reality being a fragile bubble or a grand computation feels abstract, let's bring the discussion back to a theory that makes it deeply personal, one that has captured the imagination of technologists and philosophers alike. The simulation hypothesis, the idea that our universe is an artificial construct, is more than a modern twist on an ancient philosophical puzzle. It's a proposal that some serious thinkers believe we might one day find evidence for. So, what would that evidence actually look like? One of the most compelling places to search for clues is in the bizarre behavior of the quantum world. At the subatomic level, particles don't behave like tiny billiard balls with fixed positions and speeds. Instead, they exist in a blur of probabilities, a superposition of all possible states, only settling into a definite reality when they are observed or measured. This quantum indeterminacy is a well-established fact of physics, but from a simulation perspective, it takes on a new, eerie significance. It behaves exactly like a processing shortcut in a complex video game. In a vast, open-world simulation, it would be incredibly computationally expensive to render every single detail of the entire world at once, from the spin of every electron in a distant star to the precise position of every grain of sand on a beach no one is looking at. Instead, an efficient simulation would only calculate the definite properties of a system when it is being observed to save on processing power. The quantum world's fuzzy, undefined state when no one is looking could be the universe's way of not rendering something until a player is nearby. The act of measurement, which forces a particle to choose a state, wouldn't be a profound interaction with consciousness, but simply the system loading the high-resolution assets because someone is now looking. Beyond the quantum, we can look for potential glitches in the matrix anomalies that suggest the rules of our reality might have seams. Some point to numerical constants that appear too perfectly tuned for life as a possible sign of intentional design. Others wonder if strange statistical quirks, like the seemingly low amount of large-scale structure in the universe, could be hints of a limited rendering distance. And then there are the more popular, if less scientific, anecdotes like the Mandela effect, where large groups of people share a distinct memory that contradicts documented history. While easily explained by the fallibility of human memory, the tantalizing question remains: could these be residual memories from a previous version of the simulation, a software update that slightly altered the past and left some users with outdated data? Yet, even if we could prove we are in a simulation, the discovery would unleash a tidal wave of ethical dilemmas that would dwarf the scientific implications. The most immediate and profound question is this: if this is all a simulation, is suffering real? If a simulated character experiences pain, loss, and despair, does that pain have moral weight? Does it matter if the neurons firing are made of biological matter or lines of code, if the subjective experience of agony is identical? This isn't just a thought experiment, it strikes at the heart of how we treat each other. If we devalue experiences because they might be simulated, we risk justifying unimaginable cruelty, creating a hellscape for conscious beings because we deem them less than real. The ethical imperative might very well be to act as if it is all real, because for us, the characters living inside, it is the only reality we have ever known. This leads to a second, equally disturbing ethical frontier: our own potential to become creators. Our rapid progress in virtual reality and artificial intelligence suggests that one day, we might possess the technology to create hyper-realistic simulations of our own, populated by complex, self-aware digital beings. If we are in a simulation, then we would almost certainly be obliged to create such simulations ourselves, either as a way to understand our own origins or simply because we could. But in doing so, we would be responsible for creating countless conscious entities, trapping them in a reality entirely of our making. Would we have a moral duty to ensure their world is free from suffering? Would running a historical simulation that includes wars, plagues, and natural disasters be an act of unimaginable sadism? And what would that say about our own potential creators? The simulation hypothesis doesn't just make us question the nature of our reality. It makes us confront our own potential role as gods and forces us to ask if we would be benevolent ones or something far more terrifying. Expanding on the dark forest hypothesis, we move from its chilling core principles to the brutal practicalities of cosmic survival, painting a picture of interstellar relations not as diplomacy, but as a perpetual high-stakes Cold War. If every civilization is a hunter in the dark, then their primary goal isn't exploration or communication. It's operational security on a galactic scale. The first and most vital technology any surviving species would develop is not a faster-than-light engine, but a perfect cloak. They would become masters of stealth, learning to hide their planet's atmospheric biosignatures, to mask their star's light with theoretical megastructures like Dyson spheres designed not for energy collection, but for concealment, and to eliminate all detectable electromagnetic leakage from their world. Their entire civilization might exist in radio silence, their networks hardwired with fiber optics, their broadcasts intentionally scrambled into noise. The ideal state for a species in the dark forest is to become a ghost, utterly undetectable, listening intently to the silence while making absolutely no sound of their own. But stealth alone is not enough. A civilization must also assume that its cloak will eventually fail, or that a more advanced hunter will develop a better sensor. This is where the theory descends into its most terrifyingly pragmatic form, the doctrine of preemptive strikes. In this environment, the moment a civilization detects another, perhaps a faint, uncloaked radio signal from a nascent species like ours, or the thermal signature of a poorly hidden megastructure, it faces a simple, horrifying calculation. It cannot know the other's intentions. It cannot risk communication, as any reply would reveal its own position to every other hunter in the forest. The only logical move is to immediately and utterly destroy the target before it has a chance to do the same. The weapon of choice wouldn't be invading fleets which are slow and detectable. It would be a relativistic kill vehicle, a dense projectile, perhaps just a meter wide, accelerated to a significant fraction of the speed of light. Silent, cheap, and utterly unstoppable, it would strike its target world with the force of a gargantuan asteroid impact, sterilizing the planet completely. The attack would be untraceable back to its source, and the hunter could return to perfect silence, having neutralized a potential threat with cold, mathematical efficiency. This grim reality leads to the ultimate expression of cosmic paranoia, the dead man's switch. A sufficiently advanced and cynical civilization, having hidden itself for millennia, might decide that even its best efforts could one day be thwarted. Their final act of defense, therefore, would be to create a system of vengeance. They would seed their solar system, or even nearby interstellar space, with autonomous weapons platforms programmed with a single, simple directive. If all signs of life on the homeworld suddenly cease, if the civilization's continuous, all-clear signal stops broadcasting, then these hidden sentinels activate. They would immediately unleash a wave of relativistic projectiles not at the suspected attacker, but randomly at every single potentially habitable world within range. The goal is not victory, but mutually assured destruction on a galactic scale. This ensures that any civilization audacious enough to launch a successful first strike would not enjoy its victory for long. They would be condemning their own world and countless others to annihilation shortly thereafter. This transforms the dark forest from a place of silent hunters into a forest rigged with invisible tripwires attached to bombs, where a single misstep by anyone could trigger a wave of extinction that cascades through the entire galaxy. What does all this say about the potential nature of any aliens we might meet? It suggests that the only civilizations we could ever possibly encounter are one of two types, and both are utterly terrifying. The first type is the hopelessly naive, like us, a young, loud, and noisy species that hasn't yet learned the rules of the forest and is still lighting signal fires, utterly oblivious to the predators lurking in the shadows. These civilizations would be incredibly rare because their lifespan would be cosmically brief. They would be eliminated almost as soon as they are detected. The second type, the only one likely to have persisted for millions of years, is the one that has fully internalized the dark forest logic. They would be ancient, paranoid, and ruthlessly pragmatic. Their psychology would be unrecognizable to us, forged not in cooperation but in perpetual, existential dread. They would not be curious explorers, they would not be benevolent guides. They would be survivors, and their defining trait would be a willingness to commit genocide on an unimaginable scale as a routine precautionary measure. They would value their own survival above all else, and the continued existence of any other life form would be considered, at best, a temporary and unacceptable risk. If we ever do receive a message from the stars, it will not be a greeting. It will be the last thing we ever hear. The silence that follows was the warning we failed to understand. Beneath the elegant mathematics of the multiverse lies a far more terrifying implication than simply different choices. If reality truly branches with every quantum possibility, then it doesn't just contain every happy accident and fortunate turn of events. It must also contain every conceivable nightmare, every atrocity, and every form of suffering that the laws of physics will allow. An infinite number of universes doesn't just mean a world where you won the lottery. It means there are realms of existence so horrifying they defy our very comprehension. Picture a dimension where a fundamental constant is slightly different, a place where the weak nuclear force is stronger, preventing the nuclear fusion that powers stars. This would be a universe in perpetual frozen darkness, a void where matter never coalesced into suns or planets, and life never had even the faintest chance to begin, an eternal, silent tomb on a cosmic scale. Other branches could hold more active, gruesome horrors. Imagine a reality where a virulent plague evolved not to kill its host, but to hijack the nervous system, turning all advanced life into a writhing, conscious biomass, a single, planet-wide organism trapped in unending agony. Or consider a universe where a dominant, hyper-intelligent species evolved not from social mammals, but from something like parasitoid wasps, a civilization built upon a foundation of mandatory, ritualized cruelty. Their entire concept of art, family, and progress might be inextricably linked to the infliction of suffering, making their reality a hellscape for any other form of life. The infinite multiverse doesn't just suggest these worlds might exist. It demands that they do, in numbers that dwarf all the benevolent and neutral realities combined. We don't live in a multiverse of possibilities. We may live in a multiverse where unspeakable torment is the statistical norm. This raises a question that shifts the fear from the abstract to the deeply personal. If these nightmare dimensions are real, what prevents them from spilling into our own? The standard physics of the many worlds interpretation suggests these branches are forever separate, like parallel pages in a book that can never touch. But our understanding of cosmology is incomplete, and some theories suggest these barriers might not be as absolute as we think. One of the most perplexing mysteries in astronomy is the existence of a colossal void known as the cold spot in the cosmic microwave background. This vast, eerily empty region of space defies easy explanation. One provocative hypothesis is that it isn't a feature of our universe at all, but the cosmic bruise from a past collision with another universe in the multiverse foam. If such an impact is possible, it means the walls between realities might be thin enough to bump, however rarely. The true terror, however, may not come from a random collision but from deliberate invasion. If a civilization in one of these nightmarish branches achieved a technology that allowed them to perceive or even tunnel into other quantum branches, our universe could appear as a pristine, undefended resource. A society built on conquest and suffering wouldn't see us as neighbors. They would see us as livestock or a new territory to colonize and corrupt. Their method of attack wouldn't be fleets of ships as we imagine them, but something far more insidious, a rewriting of local physical laws. They might project a bubble of their own reality into ours, a zone where their constants override our own. Within this expanding sphere, our matter would unravel, our chemistry would fail, and our very atoms would reconfigure according to their alien physics, effectively deleting our universe and replacing it with a patch of theirs. There would be no war, no battle, just silent, unstoppable erasure. Our first and only sign of an extra-dimensional invasion might be a wave of nothingness, a perfect sphere of changing laws expanding at light speed from a point in deep space, and by the time we saw it coming, it would already be far too late. But perhaps the most profound and unsettling consequence of time's end is the fate of information, the very record of existence. In a cosmos approaching heat death, no new events occur. The universe becomes a static, unchanging fossil, but a fossil preserves a story. In this final state, there is no one and nothing left to read it. Every triumph and every tragedy of every civilization that ever existed, from the birth of the first star to the last thought of the last conscious being, becomes encoded in the frozen, random arrangement of particles. The information is not lost, but it is rendered utterly meaningless. It is a library where every book has been written, but every page is blank to an audience that will never come. There is no future observer to learn from the past, no entity Chinese letter it meaning or context. The entire history of the cosmos becomes a story told to an empty room forever. This leads us to the ultimate paradoxical question. If a universe exists where time has no arrow and no meaning, does it even have a history? From the perspective of the block universe, where all of time exists at once, the answer is yes. The past is eternally there, a fixed part of the four-dimensional structure. But from within that universe, during the Dark Era, the concepts of past and history become incoherent. With no energy flow, no change, and no consciousness to experience a sequence of events, the very idea of a timeline dissolves. The universe doesn't forget its past. It enters a state where the past, as a meaningful concept, simply ceases to apply. The cosmos doesn't end with a bang or a whimper, but with the silent, final loss of its own narrative. Yet, even in this seemingly absolute finale, a bizarre form of resurrection might be possible, though it offers no solace for anything we would recognize as life. Over timescales so vast they make the current age of the universe seem like a single heartbeat, quantum mechanics provides a loophole. In a perfectly uniform, lowest energy state, a random quantum fluctuation could, given enough time, theoretically trigger a new Big Bang. This isn't a cyclical bounce driven by gravity, but a random, spontaneous nucleation of a new space-time bubble from the ashes of the old one. A new universe with its own laws of physics and its own arrow of time could burst into existence from the quantum foam of the ancient dead void. But here lies the final, crushing blow of this theory. This new universe would be born entirely causally disconnected from our own. It would not be a rebirth of our cosmos, but the beginning of something entirely new. No information, no memory, no echo of our existence could possibly cross over into this new reality. Our entire universe, from its glorious beginning to its frozen end, would leave no more trace on this new creation than a soap bubble leaves on the empty air after it pops. The cycle of death and potential rebirth offers no continuity, no legacy, and no meaning. It is the ultimate cosmic reset button, erasing everything that ever was to make way for something that can never know what came before. The end of time, therefore, is not just the end of change. It is the final and absolute guarantee of oblivion, ensuring that even if reality itself flickers back to life elsewhere, our story, and every story, is and always will be forever finished. From the haunting possibility that you are a momentary Boltzmann brain floating in the void to the terrifying gamble that we are living in a fragile false vacuum, poised to collapse at any second, these theories don't just unsettle us, they fundamentally rewrite the rules of existence. We've journeyed through a cosmos where reality itself might be a grand simulation, a holographic projection, or a single page in an infinite book of parallel worlds. We've confronted endings of ice and fire, from the silent, eternal chill of heat death to the violent, instantaneous erasure of a vacuum decay or a brain collision. And perhaps most chillingly, we've considered that the profound silence of the cosmos is not emptiness, but a dark forest, a warning that every other civilization has learned to hide from a universe that may be inherently hostile. These ideas challenge the very core of what we believe to be real. They force us to question whether our memories are our own, whether our choices are truly free, and whether our consciousness is a rare miracle or a fundamental property of a universe that is itself aware. They transform the universe from a familiar, if vast, expanse into something profoundly alien, a place that might be indifferent to our suffering, hostile to our existence, or worse, an illusion that could be switched off without a moment's notice. This leaves us with a final, deeply personal question to ponder, one that all these theories point toward but can never truly answer. When you look up at the night sky, what feeling does it now evoke? Do you see a universe that is fundamentally friendly, a place waiting for us to join a grand cosmic community? Do you see a universe that is utterly indifferent, a cold, mechanical clockwork that neither knows nor cares that we are here? Or do you see a universe that is inherently hostile, a dark forest where survival demands silence and paranoia, and where the only logical outcome for a naive, noisy species is a swift and anonymous extinction? We want to know which of these 25 theories got under your skin the most. Did the existential dread of the Boltzmann brain resonate? Does the silent, calculated horror of the dark forest keep you up at night? Or is it the sheer, incomprehensible scale of the multiverse that makes you question your place in it all? Let us know in the comments below. Share your thoughts and your own chilling theories about the cosmos. If you enjoyed this deep dive into the universe's darkest secrets, make sure to like this video and subscribe to the channel for more journeys to the edge of reality. The mysteries are endless, and we've only just begun to explore.